Okay, kiddos, welcome to another episode of Finger Painting with Mr. Renard. So I left my stylus at work, so sorry about the increased lack of clarity. Okay, so this is the assignment from 6162, and first part of the assignment is going to be related to interior angles and exterior angles of polygons. Second part is dealing with an intro to parallelograms. So we start off with this, which is, I believe, number 7. So we're being asked to find the value of h. And what we need to do first is realize that all 4 of those are going to add up to 360 degrees. We do that by applying the Polygon angle sum theorem, which is, if you don't remember, n minus 2 times 180. And that is, again, the reason we do that is because that's the number of triangles we can create. Here we have 4 sides, n is the number of sides. We can cut that into 2 triangles. Each of the triangles is going to have interior angles of 180 degrees. So what we do is we go 4 minus 2. So here we have 1, 2, 3, 4. Don't mistake those for hash marks. Saying that they're equal sides. So we go 4 minus 2 is 2 times 180 is 360. So we know that all 4 of those have to add up to 360 degrees. And so that gives us, we add all 4 of those up, 2h plus 2h plus h equals 360. 1, 2, 3, 4, 5, 6. That's 6h equals 360. Divide by 6, and we get h equals 60. For some reason I just write down 6, but don't worry, I'll put the 0 there in just a second. So, and we can double check that by plugging it in and getting that we had 120, 120, 60, 60. And that gives us 120 and 120 is 240. Add another 120, 360. That's what we started with. So that's number 7. Okay, now we're going to do number 19. And we're looking for a 36gon. And what they're asking us to do here is to find the exterior angle. Okay? So that's that red one right there. It's the one outside the triangle. Just like we did the exterior angle theorem with triangles, we're going to do it with polygons. So if we were to extend one side of a polygon past the vertex, the angle that it formed with the other side of the vertex would be the exterior angle. So 36gon, now what we need to understand is that all exterior angles, and this is the exterior angle sum theory, add up to 360. It doesn't matter whether you have 3 sides, 4 sides, 5 sides, or 8 billion sides. They're always going to add up to 360. Remember Andy Angle and his trip around Triangle Mountain. So we know that exterior angles equal 360 divided by n. And this has to be in a regular polygon. And number 19, the intro to those sets of problems do say that those are regular polygons. So we know that because it's a regular polygon, it's equal angular and equal lateral. Now what that also means is that each one of these angles is each one of the exterior angles is going to be the same. So if we break up all 36, because it's a 36gon, all 36 of these exterior angles, we're going to get, they're all going to be equal. So we divide 360 by the number of exterior angles, and that's going to give us the measure of each exterior angle. So we know that n is 36 because it's a 36gon. We go 360 divided by 36, and that gives us 10. So because it's a 36gon, that's 36 sides, each angle, exterior angle, is going to equal 10. Now, moving on, I believe this is 23, 25, something like that. What we're being given is the sum of the interior angles. Here it's 1080 degrees. Now previously we had the equation, the sum of the interior angles equals n minus 2 times 180. And that's how we got 360 back on that first slide. Here, instead of being given n and solving for the sum, we're being given the sum and solving for n. So we just plug that in, 1080 equals n minus 2 times 180. So now we just apply algebra. We want to isolate that n. We want to find out how many sides this has. So we divide both sides by 180. And 1080 divided by 180 is 6. That gives us 6 equals n minus 2. We're going to add 2 to both sides, and we get n equals 8. If we wanted to double check that, we could plug that back in. N minus 2 is 6. 6 times 180 is 1080. It all checks out. Moving on, this would be number 31. Okay, so this is actually extremely similar to that other one. Now, normally when we think about exterior angles, we think about them kind of all going the same way. So if we have that exterior angle there, we're going to have this there, and there. So we have 3 angles, and notice how they're kind of all going the same way. We go counterclockwise, and we run into the same angle each way. Now, the fact that doesn't really change what the exterior angle sum theorem says. The exterior angle sum theorem states that all of the exterior angles have to add up to 360, and there's 1 at each vertex. Now notice here we have 1, 2, 3, 4. 4 vertexes. We have 1 angle at each one. Now, if we were to look at this and try and make them each way, what we'd find out is if I extend this, I'm having a little difficulty here. If I extend this side right there, that's x2, because those 2 sides are going to be vertical angles. So the fact that it's just kind of written a little wonky doesn't actually change how we do this. We know that all exterior angles equal 180, or 360 rather, so all 4 of those are going to equal 360. And then we just set up our algebra problem. 2x plus 3x plus 4x plus x equals 360. 4, 5, 6, 7, 8, 9, 10. So we get 10 x's equals 360. Divide both sides by 10. We get x equals 36. So that'd be the answer to number 31. 35. So here we're being given the measure of the exterior angle, in this case it's 30, and we need to find the number of sides and then the measure of the interior angle, not necessarily in that order. We know that interior and exterior angles, by their definition, are supplementary, right? So we know that 30 plus whatever the interior angle equals 180. So hopefully this picks up roughly where we were. 30 at a computer issue. So 30 plus the interior angle equals 180. The interior angle then equals 30. We get that by subtracting 30 from both sides. We also know, and if this doesn't make sense, go back a couple slides to the one where we talked about exterior angles. We know that the number of sides equals 360 divided by the measure of the exterior angle. So we have 360 divided by 30, and we get that there are 12 sides. Okay, now moving on, number 9. So this is now we're talking about parallelograms. So we know that parallelograms, and you should have this in your notes, have specific properties. The opposite sides are both congruent and parallel. We know that their diagonals, let's back up, so it's 1, opposite sides, parallel. And that's actually the definition of a parallelogram, is we have two sets of parallel lines. We then also know that because they're parallel, they're congruent. We also know that the diagonals bisect each other, like so. We know that opposite angles are congruent, and we know that consecutive angles are supplementary, so they equal 180. So when we look at number 9, we're going to go off of those. If those don't make sense, if you need that, just rewind the video, rewatch that again, and write them down. Have those notes. So we're looking at those two angles. So those two are consecutive angles, so we know they're going to be supplementary. That means they equal 180. And we're given 53 and x. So we know that 53 plus x equals 180. Just subtract 53 from both sides, and we get x equals 127. Okay, so I totally forget what number this is. I believe it's like 15. And I left out the letters, but it's like P, Q, R, S, T. Okay, so as we just stated, we know that diagonals bisect each other. So if the diagonals bisect each other, then what we can do is we can write down that 2x equals y plus 3, right? Because we know that this area and this area are the same. We then also know that this and this are the same. So we can further write that y equals x plus 2. So what we do now is we treat this like a system of equations, which you should be familiar with from algebra. And we already have that y equals x plus 2. So that means that if y equals x plus 2, we can sit there, we can substitute that in for the y in the other equation. That gives us 2x equals x plus 2 plus 3. So now we have an equation with only one variable, and we can go ahead and go 2x equals x plus 5. Subtract x from both sides, and we get x equals 5. We're then going to go back up, and we're going to plug that in for x, this one specifically. That's the y. It's actually this x right here that I'm looking at, the one I just erased basically with the red. So we have 5 plus 2, so we get y equals 7. Now if we go back and plug that in, we can go there. 5 times 2 is 10. 7 plus 3 is 10. 5 plus 2 is 7, and y equals 7. So we're good to go there. And this is our final one. And I think this is 30 something, like 35. So we have 6a plus 10 and 130. Now again, the rule states that in a parallelogram, the opposite angles are congruent. Here we have 6a plus 10 and 130. We know that they are congruent, which means that they are the same, so we can set them equal to each other. We're going to subtract 10 from both sides, so we get 6a equals 120. And we divide by 6. And we divide by 6, and we get a equals 20. If you have any questions, go ahead, email me. Let me know what you're having problems with, and we'll go from there. Thank you all very much, and have a wonderful evening. See you guys tomorrow.